and I'd like to welcome you to Leeds LitFest. On behalf of Millim and Leeds LitFest, we really appreciate your time and support in joining us. Before I introduce this event, I'd like to say just a few words on behalf of the 9 Leeds LitFest partners. At this time, it has never been more complicated to deliver a literature festival, but in our view, never more important for the festival to happen. To make the festival as accessible as possible, we are offering a mixture of in-person and online events. We realise that these are not easy times for anyone, but if you haven't already done so, it would be appreciated if you could make a donation to the festival to ensure that we can return next year. Details of how to donate are at the bottom of your screen or on the Leeds LitFest website at leedslitfest.co.uk. Our guest today is environmentalist and best-selling author Jonathan Drori, whom I'm delighted to welcome to Leeds LitFest and delighted also to welcome back to Millim. And I'll introduce John in just a moment. Please do ask questions. You can do this by typing whatever you'd like to ask into the Q&A facility on your screen. And as is always the case, we'll try our very best to get through as many of your questions as possible. Can I also draw your attention to the chat facility? This can be used to send a message or comment to all of the other participants on this webinar, should you wish to do so. And finally, this event is being recorded and will appear on the Millim website at millim.org.uk in the next few days. There you will find recordings of other past events, as well as details of our future programme for which you can book tickets. And so to our speaker this evening. Jonathan Drori is a trustee of the Eden Project and the Raspberry Pi Foundation and is a member of the Council of Ambassadors of the WWF. He has previously been a trustee of the Royal Botanic Gardens Kew and the Woodland Trust. He was executive producer of more than 50 popular BBC television series on science and technology, and his TED Talks have been viewed many millions of times. His book, Around the World in 80 Trees, which he's speaking about this evening, has been translated into 19 languages, and regular Millim viewers will recall John's talk about his other book, Around the World in 80 Plants, just a few months ago. John, we're really excited to hear what you've got to say this evening, so without further ado, over to you.
Thank you very much. I'm going to, a miracle of technology, I'm going to try and share my screen. Let's see how this goes. And then I have to put it into presentation mode. And then I've got to show presenter view. And then finally, I've got to do this with the laser pointer. So can just tell me if
looks good, looks
can you
perfect.
See my little laser pointer?
Yes, it's fine.
And fine. You're seeing the full screen. Great, brilliant, thank you. Well, good evening, everyone, and thank you very much for coming. This is very strange. You know, here I am in a little room in North London, and I'd love to be with you, but maybe next year. If you do have questions about trees, about anything I say, or about plants in general, then that it's always more fun when there are sort of questions at the end. So have some ready. And the thing I can tell you, it's going to hurt a lot less if you have some fruit juice or something with you. So I'm going to talk for about 40 minutes, I hope, but it's very good timing right on Zoom. And I'm going to start with just reading a paragraph from the book. One of my earliest memories is of a spectacular cedar of Lebanon near our home. One winter morning, we found it dead, its trunk and limbs strewn haphazardly and being sawn up. It had been struck by lightning. That was the first time I saw my father cry. I thought about the huge, heavy, beautiful tree that was hundreds of years old and that I had thought invincible and wasn't. And my father, who I had thought would always be in benign control of everything and wasn't. I recall my mother saying that there had been a whole world in that tree. I remember puzzling over that. But my mother was right. There was a whole world in that tree. And so there is in every tree. They warrant our appreciation, and many of them need our protection. That's just from the intro to the book. And here's me with my dad when I was about 6, and he's wearing a suit to go to Royal Botanic Gardens Kew on a Saturday afternoon, because that's what people did in those days. And the way that he and my mum sort of jollied me along and got me and my brother interested in plants was essentially by feeding us bits of them. So he fed us bits of Dieffenbachia, which if you've ever got that as a pot plant, it says do not feed to kids or dogs or cats. And he told us the story of slavery through that plant. In America, it's called dumb canes, and it contains a poison. It's a very well-known pot plant, but it contains a poison that is accelerated into the lining of your mouth by these very sort of needle-like crystals inside the cells. And he also gave me a lick of an opium poppy, which had much more effect on my teachers than it did on my tongue when I told them about how my parents had fed me opium, and they sent around a social worker. But this sort of gave me a love of plants and an interest in plants that lasted a very long time, and in particular with trees. So I was lucky enough to be a documentary filmmaker for a while with the BBC, and I got to travel, and then subsequently with Kew Gardens on various expeditions. And the thing that kept striking me was this sort of fantastic diversity. These wax palms in Colombia, I mean, ridiculous. That's a tiny little person that you might be able to see at the bottom of the screen there. These quiver trees, or this quiver tree in Namibia, in the desert. That's my wife at the bottom of this coastal redwood, a hugely tall tree. I mean, incredible variety. And as I travelled, I thought about these trees and how they've all evolved into their own particular niche. These baobabs, which look as if they've been flung in upside down, fantastically good at storing water. This dragon tree in Socotra off the coast of Yemen, where any dew or rain gets funneled down to the center of the tree and then down to the roots, funneled because the sort of water runs along those branches that all sort of converge like an umbrella. So I'd like to talk about trees from the point of view of trees themselves. They're trees, they're things that we usually just sort of, people are sort of have this kind of blindness really about plants and trees. And the first question, let's talk about food first, and then we'll talk about water and defense and all sorts. But so trees need food, and here's a question for you. A little seed weighs next to nothing, and a tree weighs a lot, and a bag of charcoal that came from the tree, that weighs a lot, right? So where did all the stuff come from? Where did all the mass come from? And I know from my research that about 85% of the audience would say it comes out of the ground. Well, I don't know if you have things differently in Leeds from North London, but we don't have lorries driving around at night filling in all the earth that the trees have taken out of the ground here in London. And if you look carefully at this row of trees here, they haven't taken a sort of a whole load of soil out of the ground. If you have a pot plant, you'll find that you don't have to top it up very often. And the thing is that the two main ingredients that trees are made of, the two main things that make up the mass of the bulk of the heavy stuff, there are just two ingredients. And those ingredients are water, which comes up from the roots, which is actually part of the chemical reaction, carrying stuff around, and carbon dioxide, which is a heavy gas that's invisible, that's in the air. And so all of the carbon that's in the charcoal, all of that came out of the air, and it gets into the trees through the leaves. So that's the answer to the question, is where did all the stuff come from? Comes out of the air. Now, the next thing that trees need is water. And water, as I say, is one of the ingredients of the photosynthesis reaction, which is powered by sunlight. But it's also useful as a medium for the tree to sort of carry other nutrients. It doesn't need very much of those, but carry other things around the tree, sort of sugars and trace minerals and things. And if there are any engineers in the audience, you'll know that pumping water up to the very, very tippy top of a very top thing is actually really hard. You know, the pumps that do this often fail, and they're not, you know, and they require a lot of power and so on. And so, you know, you might wonder, how does a tree get the water all the way up to the top? Now, I've got a little message saying my internet's unstable, so I hope you can still hear me. But anyway, the way that the tree sort of gets the water to the very top of the tree is that there's a kind of evaporation that happens at the top through the leaves, and that creates a little vacuum. And the little vacuum kind of draws a column of water all the way up the tree. Now, here's the thing. It turns out that all the very, very tallest trees in the world, either that exist now, and they're mostly coastal redwoods, but not all coastal redwoods. There are some other species that are very tall as well. All the very tallest trees, wherever they are in the world, and in the fossil record as well. So the biggest Douglas firs, the biggest mountain ashes, and so on. They're all the same height. They never get higher than about 120 meters or so, which is very, very high. But if you look at the fossil record, that's as tall as they've ever been. And the thinking is among scientists that the reason for this is that's the limit to which you can draw a column of water up. And any taller than that, and there's what breaks down is this thing called molecular cohesion. Now, stick with this for a second. If you wear an anorak out in rain, you find that the droplets form, the rain forms little droplets. Now, oil doesn't do this, alcohol doesn't do this, but water does. It's got this quality of sort of cohering to itself. It pulls itself together. And that molecular cohesion is what allows a column of water to be drawn up through the tree. Now, if the tree is longer than about 120 meters, it turns out that the hydrogen-oxygen bonds in the water are just not strong enough to hold the water together, and the column breaks. Now, I love that, because it means that anywhere in the universe that there are trees on a planet which has the same sort of gravity that we've got, they'll only be as tall as the tallest trees on Earth, which is about 120 meters. Isn't that fab? So given that trees are made of carbon dioxide and water, and carbon dioxide is something we've got too much of in the air, you can see that planting a lot of trees is a good thing to do, generally, if you plant the right trees in the right places. And also, anything that stores wood, rather than sending it back into the atmosphere if you allow it to decay, is a good thing. And therefore, everyone, buy more books. It doesn't have to be mine. Buy more books, because obviously then you're sequestering more carbon out of the air. Now, I'd like to tell you about the relationship that trees have with something called mycorrhizal fungi. Now, that's a fantastic word for Scrabble. Impresses the hell out of people. I'm just going to read you a little bit about mycorrhizae. Now, what you're seeing in the picture there is a tree root, which is the sort of right angular bit here. And the very, very fine filaments, these tiny little bits here, are fungi. Okay, so the tree lives in a sort of symbiotic relationship, most trees do, with fungi, because the fungi can extract more from the soil in the way of these trace nutrients that the tree needs than the tree can itself. Trees often develop symbiotic relationships with mycorrhizal fungi, which intermingle with their roots and extend beyond them in a huge web of minutely thin filaments. These networks are especially good at extracting nutrients from the soil, which they pass on in an easily digestible form. In return, the fungus receives sugars from the tree. Now, individual tree species cooperate with particular fungi. The birch's life partner is Amanita muscaria, the fly agaric, whose fruiting bodies, the parts we see above ground, are scarlet with white sprinkles, the archetypal toadstools of every fairy tale. Fly agarics contain a cocktail of mind-bending hallucinogens around which all manner of shamanistic rituals have evolved, particularly among Siberian tribes and the Sami people of northern Finland and Sweden. So far, so human. Many cultures have psychedelic traditions. However, the fly agaric's psychoactive ingredients are not completely broken down in the body, but excreted. This offers the enticing possibility of intoxication and a spot of social bonding by drinking the pre-drugged urine of others. It's true that northern nights are especially long, and the forests might have been lacking in other excitement. However, one can't help wondering whether this practice was really as widespread as the few historic travelers who seem to be the common source of all the shamanistic pee drinking stories were told and so eagerly reported. I'm sure you've all tried drinking each other's pee, haven't you, after trying those mushrooms? Seriously, don't try these. They're actually rather poisonous. Now, after food and water, trees need to defend themselves. They are literally rooted to the spot. They can't run away. And when an insect or some other herbivore looks at this view that you're seeing here, they probably think, lunch. So trees have evolved an incredible array of ways of defending themselves. Top left here, you can see the Pachypodium. This is a magnificent tree of Madagascar, and absolutely covered in these needle sharp, and I mean literally needle sharp thorns. The spikes on this tree from Costa Rica, the sandbox tree, which we'll come back to later, are pretty unpleasant. The manchineel in the middle here, absolutely appalling plant. Every part of it is caustic and poisonous, and how anything could eat it, I've no idea. You've got the oak trees that are familiar here, and they have tannins in the bark that disrupt the digestive systems of deer and other large herbivores. And when they're attacked by insects, they give off these sort of chemicals that actually trigger other trees nearby to create defense chemicals of their own. So whether it's a sentient being signaling or not, I'm not so sure about that, but it's certainly a signal is picked up by other trees and triggered to defend themselves. And some of those chemicals travel through those mycorrhizal networks that I mentioned. And so, sort of 30 yards away in about a quarter of an hour, a tree has been triggered through those chemicals traveling through the fungal networks to make some more of those defense chemicals that it might need. Here's cherry laurel, which is has a two-part poison in it, two chemicals that are quite innocuous, quite easily produced, held separately, and then something chomps into them, it creates cyanide. Here's coffee, which it's sort of, caffeine isn't something insects like a lot, but what it does, it's actually defending itself against other trees and other plants, because caffeine sort of prevents other plants from germinating very well. And here's an interesting example of you can see that some caterpillar or something has been eating this tree. And what's clever about this is that you might think that, in the context of defending themselves, I'm going to talk about sort of poisons or something. But actually, what the tree has done is to put a very, very sweet and lovely chemical inside this. It's not nectar, but inside the sort of exudation that comes when the leaf has been attacked. And what it does is it attracts the thing that is going to eat the thing that is eating it. Isn't that fab? I think that's fabulous. So this is one of the wonderful images in the book. I don't know how well you can see it, from Lucille Clerc. These are the kauri trees of New Zealand, the North Island of New Zealand. And this is one of the trees that defends itself with resin. And the resins are, chemicals that sort of, they can seal a wound against bacteria and viral attack. And they also sort of gum up the mouth parts of insects. And that bactericidal quality is why we often use resins like frankincense and myrrh and so on in mouthwashes. And of course, they're beautifully fragrant because they have these very volatile chemicals. The modern New Zealand wouldn't be modern New Zealand without these trees, because back in the 19th century, when the Americans were having a gold rush, the New Zealanders were having a resin rush. 10,000 prospectors arrived from all over the world with these special twangy sticks, twangy metal rods, which they popped into the ground, they twanged them, and they could hear from the twang sound whether there was a big lump of resin underneath that would have accreted over perhaps thousands of years. And these lumps of resin were, big enough for two people to be able to just about lift. I mean, they're big thing, and people were collecting it because this was the source of outdoor varnish for the British Empire. And that varnish, the New Zealanders, or at least the Europeans who colonized New Zealand, they decided to tax the proceeds of the sales of resin, and they used that to build the modern infrastructure of New Zealand, which was roads and hospitals and schools and all the rest of it. And ironically, in doing so, they chopped down the forests. Very sad. Here's another one. This is a contemporary drawing of a gutta percha tree. Now, gutta percha, you might have heard of gutties, the golf balls that allowed, which was a sort of rubbery substance and used for making golf balls back in the sort of beginning of the 20th century and late part of the 19th century. And gutta percha is like rubber. And it has this sort of latex, white milky fluid that again, gums up insects' mouthparts and acts as a sort of sealant against infection. But people tapped these trees. Indigenous people in Borneo and Malaysia had actually been using this material for probably hundreds, maybe thousands of years, for making kind of footwear from, because it's this rubber will set and you can mold things from it. But the Europeans found other uses for it. So they made all these kind of amazing kind of kitchen implements. And at the end of the 19th century, there was this huge craze for gutta percha, and there was the gutta percha company this and company that, and venture capitalists put their money in and so on. And then someone found the most amazing use for gutta percha. And I mean, it was absolutely extraordinary, and it completely changed the world. And the use for gutta percha was not in boats, but if you can see on that boat, there's a big reel of something. That is cable. And the reason they're laying that cable is so that people can have phone calls that go between countries. And obviously you need a cable that will go under the sea, right? This was the days before radio. So, the ability to talk to each other really caught on. And these cables were insulated with gutta percha. That was the only thing that was available at the time that would insulate cables from, the wires from each other and from the seawater. Before long, there were 250, there's the first cable, but then there were 250,000 miles of gutta percha insulated cables under the sea. And all because a tree in Borneo and Malaysia had evolved to defend itself using that latex. Here's another kind of sap that is you might know. This is the I'm going to talk about the Japanese lacquer tree, and lacquer is an amazing substance. They just tap a little bit of this sort of lacquer from each tree, and only over a few years, otherwise it kills the tree. And the lacquer is horribly poisonous when it's before it sort of dries or cures. But this is a polymer, and a polymer is a plastic, right? So this is thousands of years old plastic. And if you've looked at this, sort of lacquer material, if you can imagine how someone 500 years ago would think about a material which, has the same qualities as plastic. It's completely waterproof. It's light. It's very, very strong and lasts incredibly well, and it can be beautifully decorative, right? That would have been the most amazing material 500 years ago, before there was plastic in the world. They build this up on a sort of wooden base over layers and layers and layers of this lacquer. But the lacquer has another slightly sort of more squeamish side to it. Hope there aren't too many kids in the audience. And I'm just going to read you a paragraph. This is a drawing of the lacquer tree. The creepiest historical use of the lacquer tree must be that of an obscure sect of ascetic northern Japanese monks, intent on becoming Sokushinbutsu, or living Buddhas, as a route to enlightenment. The whole journey lasted several years and started with a slow reduction in the intake of food and an especially slimming diet of seeds, nuts, roots, and bark. With the intention of their corpses becoming a whole body relic, the monks then gradually embalmed or mummified themselves by drinking urushi tea made from the sap of the lacquer tree. After becoming horribly dehydrated and dying slowly, their bodies were resistant to decay and too poisonous or unpleasant even for maggots. 3 years after death, the monks' tombs were opened, and those few who had not decomposed were said to have achieved Buddhahood. Seen as assisted suicide, the practice was made illegal only in the late 19th century, and several Japanese temples still exhibit gruesomely well-preserved remains that are claimed to be those of self-mummified monks. Sweet dreams, everyone. Now here's a tree that you'll probably be familiar with, that has a lovely way of defending itself. This is the alder tree. And the alder tree often grows near water. It's got special bacteria in its roots that enable it to extract some nitrogen that otherwise waterlogged things can't really get hold of very well. But it's also incredibly rot resistant, and it's so rot resistant that the Venetians, when they built the fantastic, amazing city of Venice with incredible chutzpah right in the middle of a lagoon, they supported those buildings on alder wood piles because alder lasts so well in water. And the Ponte Vecchio, which you can see there, is still supported on the original wooden alder wood piles after 500 years. Fantastic. But alder gave something else to Venice. And alder, those of you who read military manuals on gunpowder making will know that the best gunpowder is made out of alder wood, charcoal. And the Venetians used alder wood for making charcoal, which was very important to them for smelting steel. And they smelted the steel in a forge, which was called the ghetto, right? And that's what's given us the word ghetto, is because it was a sort of enclosed area. Eventually, Jews were living there, and the word ghetto came from Venice and the forge. But those forges enabled the Venetians to have both to take weaponry out of steel. And of course, that weaponry was charged with gunpowder that was made using the charcoal from the alder wood as well. So at the height of its power, Venice, using a sort of production line method, could make one ocean-going vessel fully kitted out with weaponry and so on. They could make one ocean-going warship per day. Per day. It's incredible. And so much of that was built on so much of that ability, the buildings, the gunpowder, the steel, was built on the alder, which of course evolved for its own good reasons to be able to survive in water. And here's the whistling thorn. This is an acacia that grows in East Africa. And you might be able to see these fantastically sharp thorns. You'd think that's the way it's defending itself against things from eating it. And that is the way it defends itself, except for an elephant. Those thorns are neither here nor there. And this needs to stand up against elephants. And the way that it does that is by having this wonderful relationship. That thorn has this sort of spherical house at the base of it. And that's a home for these killer ants. They are really the most horrible ants ever. You touch them and they'll bite like frenzy. In fact, if two trees swish against each other, the ants, two different colonies, will fight to the death until they've all killed each other. So it's really unpleasant stuff. Now, elephants know to stay away from this. And one of the reasons they know to stay away is that the wind, when it goes through those thorns, actually makes this kind of whistling sound. And you only have to play that whistling sound through a tape recorder to an elephant, and the elephant kind of backs off. Yeah, amazing, because it's learned to associate the sound with pain. And of course, for the tree, it's getting protected. That's the tree's view. Here's the beech tree. Virgil complained that people were using the beech tree as a sort of tabula rasa for doing graffiti on, even in his day. And you know, what a hypocrite. He went and carved his own name in it, having complained that other people were doing it. But there's an interesting defense of this tree, actually, against lightning. Now, in Germany, there's a saying that lightning never strikes a beech tree. And actually, lightning strikes beech trees just as much or as little as every other tree. But beech trees survive. And the reason they survive is because if there's a lightning strike, it's likely to be raining, right? And the rain on a beech tree provides a very smooth surface, because the way that the bark is on a beech tree is very, very smooth, because it's constantly sort of getting rid of all the little sort of particles and renewing itself. So beech tree, very, very smooth. It's wet all the way down, which means that the bark acts like a lightning conductor. If lightning hits it, the electricity flows down the outside of the tree through the liquid, you know, the good conductor that is water, and down into the ground. It doesn't damage the tree. On an oak tree, however, there's all those craggy bits that are dry, which means that the electricity from the lightning preferentially goes through the middle of the tree where there's more liquid, and zaps the tree and kills the tree. So I like that sort of defense that it's evolved. Now, having defended themselves, trees need to make more baby trees, right? And there are essentially two ways of doing this. One is through asexual reproduction, in other words, cloning itself. So this is what aspens do. It's great after a fire, you can quickly repopulate an area. The trouble is that if you clone yourself, then you're also vulnerable to disease, because if a tree is vulnerable to if one tree is vulnerable to a disease, then they'll all get it. So this is the problem with bananas. Banana plants are cloned because we've bred them to be sterile and not have seeds in the bananas. We don't like having seeds in bananas. So all the plants are cloned, they're all identical. So if there's something that, either a fungus that attacks one sort of banana plant somewhere in the world, all the banana plants potentially can be affected. So there's another way of that trees and all plants have developed in order to propagate themselves, to reproduce, and that is using pollen. So grasses do this. They throw out masses and masses of pollen into the air that contain the male sex cells. And if that pollen lands in the right bit of a female flower, then you'll get another plant, right? Or at least you'll get a seed of another plant. And this is an incredibly inefficient thing to do. You can imagine you just have to throw out all this pollen, which is tiny, 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 weeny stuff, and hope that it arrives in the right place. And this is why the things that we're allergic to, this incredibly sort of bioactive material in pollen, if you know, we're allergic to the things that are wind pollinated, right? Because they have to make so much of it. And you know, so the alder that I mentioned, that's wind pollinated. And under a microscope, these things look great. You know, there's willow pollen, very aerodynamic, so it travels a long way. Hazel and walnut, sycamore. Surely there's a better way. Yeah, I mean, it's just so random, isn't it? Just throwing it to the air. And the better way is that you get an insect or some other creature to do your bidding, something that will take the pollen exactly where it needs to go. But if you do that, you have to give the insect or the other creature something in return. And that's how flowers work. Okay, so the idea of a flower is to look attractive, to be attractive, to use scent to attract and sight to attract. You know, so things that are insect pollinated are beautiful. They're, you know, got colors and so on. They have these lovely flowers. And in return, the insect will get some nectar. And the nectar contains lots of sugar. And the insect will fly off to the next flower, thereby taking the male sex cells to the other flower, pollinating it, and you can get a seed as a result. So the plant gains, the insect gains. So this is an interesting sort of plant that this you probably recognize. This is horse chestnut. And the horse chestnut has this sort of clever relationship with insects in that it changes the color of each of these little florets that you can see. So this isn't one flower, this is a whole lot of little flowers. It changes the color once it's been visited by an insect, so that it sort of saves the insect having to spend more time and effort, you know, sort of visiting them. And that's good for everyone. It's better, more efficient pollination. And the way that it does that is it changes this from yellow to red, and red is something that's not seen very well by insects. That's why if you've got a wasp's nest, you need to clear it at night with a red filter over your torch. And so for the insects, it probably sees something a bit like that, and is much more attracted to the yellow flowers. And the horse chestnut in the book, rather poignantly, I realized only after I put this slide deck together, given what's going on at the moment in the world. This is Kiev in Ukraine, where which I chose as the place to represent horse chestnuts in the book, long before all this blew up. The Ukrainians really have taken the horse chestnut to heart, and Lucille has drawn some little kids and someone playing conkers here. It's the Ukrainians in Kiev that sort of lead on this. So if insects don't see red, why is this tree bright red? I hear you ask. Well, things that are, sometimes we've bred trees to be red, but the ones that are naturally red, they're not going to be pollinated by insects. In this case, it'll be a bird or perhaps a butterfly, the flamboyant. Birds and butterflies see red extremely well. The durian fruit, the bane of Malaysian Airlines, when people bring them onto the plane and people think that, you know, something's rotten in the air conditioning. The pollinator for these big white blousy flowers that smell slightly of sort of sour milk and come out at night are bats, incredibly important pollinators. You can just see them covered, or her, I don't know how to sex a bat. They're covered in pollen, and they'll you know, the plants that are bat pollinated have to make absolutely pints and pints of nectar, and the bats will come an awful long way in order to pollinate them. And this is how baobabs are pollinated. Trees having been fertilized need to spread their seed, and the seed you can persuade squirrels to plant your seeds. Squirrels are fantastically forgetful, will plant a whole load of seeds thinking they'll dig them up later and then forget about them. And the tree has not only dispersed its seeds, so it's not competing with the mother tree, but has also managed in the process to to have it planted. The cannonball tree, you'd think, well, nothing's going to disperse that, but actually these sort of wild pigs in South America called peccaries, they do that, and kapok, distributed on the air. These things that are bird pollinated have berries or seeds here that show up very well to birds. So if you looked at them through the spectrum that a bird sees, these things really stand out. A lot of fruits are very laxative. The reason for that is that you don't want your seeds to be inside the digestive tract of an animal for too long, because that's quite an unpleasant place for a seed to be. Much better that they eat the fruit, that you don't want them to chomp on the seeds. So the seeds are often very bitter, often very poisonous. And then they get pooed out fairly quickly, along with a little pile of handy fertilizer. So that's why fruits are mostly laxative. The coconut, dispersed by water, is you might think that the coco de mer, which is the largest seed on the planet, the size, the weight of a carry-on suitcase. And I tell you, if you're camping under one of these in the Seychelles, you really shouldn't be camping there, because if that fell on you, you know about it. But in the 18th century, for some reason that I'm sure you can imagine, these were seen as the most fantastic aphrodisiac. And they probably cost about £150,000 in today's money, about £400 at the time, and only royalty could afford them. And then only royalty was allowed to have them. They sort of passed laws saying that only royalty could own them. Wonderful aphrodisiac. And the way that this thing stops itself from, when it plummets to the ground, from competing with the mother tree, is by sending out a kind of umbilical cord, like about 12 meters over there, and then it sort of grows from over there, using the nutrients from here for a couple of years. Incredible. I've almost finished. If you're concerned about time, as I said, it's difficult to keep the time on Zoom, but just into the last couple of slides. So this is the sandbox tree, which I mentioned at the beginning. From this was taken in Madagascar, but from Costa Rica originally. And the way this thing projects its seeds is fantastic. These sort of tangerine-like seed cases, they dry off, and they dry differentially, so that there are stresses built up in this thing, like kind of a spring. And these seeds, which are about the size of a pound coin and about half the diameter of a pound coin, they come out spinning like a frisbee. And they come out at about 200 kilometers an hour. It's just fantastic. And they come out at the perfect angle, taking into account wind resistance, to travel the farthest distance possible, which is about 50 meters, which for something that is that size and that isn't terribly heavy, is incredible that it travels that far. And when these things go off, it's like hearing, sort of, a car backfiring or something. It's sort of hugely loud. There's a story about a Viennese botanist who popped one of these into a glass bell jar, and then was fortunate enough to go out for lunch, because when he came back, there were bits of the bell jar embedded in the walls. And that's one of Lucille's lovely images. Isn't that great? I'll finish with the traveller's tree. This is a magnificent plant of Madagascar, and it's called the traveller's tree. I mean, just look at that for a piece of evolution. It's called the traveller's tree because if you dig a sort of a straw into the bottom of it, you can suck out fresh water. I mean, the fresh water is kind of full of wriggly things and not very nice, but I suppose if you're really desperate, that would be okay. And the other tree, reason it's called a traveler's tree is because all these fans point in the same direction, so you can use it as a compass, or at least that's what all the textbooks say. But when I was there, I noticed on Google Earth that the fact that these palms were all pointing in different directions. And I asked the local scientists, and they said, "Oh yeah, it's something we tell tourists." Madagascan humor for you. But the thing about this plant is it's part of the same family as Strelitzia, which is this bird of paradise flower that you see in florists. And it's got these really big kind of bracts, which are the equivalent of this bit here, that sort of protect the flower before it's come out. And the only thing, that can lever those bracts apart and get at nectar and the seeds when they arrive has to be very strong. And the seeds are bright blue, which is very uncommon. There are only about sort of 2 or 3 species in the world that I know of that have bright blue seeds. And it turns out that the thing that distributes these seeds that the plant needs in order to survive is the permanently startled looking ruffed lemur. And if anything happens to the ruffed lemur, then that tree will go extinct. The ruffed lemur is okay, it can eat other things, but this tree can only have its seeds dispersed by this one animal. And so it's in great danger, this tree, in the wild. It's in botanic gardens and in gardens and so on, but in the wild it can go extinct. And this is the thing about climate change, that climate change isn't just about things getting hotter or wetter or drier. It's about the timing of everything going wrong. So if the insects that are going to pollinate, or the range of little creatures that are going to take the seeds and disperse them aren't around at the right moment, then plants can go functionally extinct. And that's one of the great worries of climate change. So look, trees need all those things. They need water, they need food, they need to be able to disperse their seeds. And above all, perhaps, trees need some love. So I hope that's what we'll give them. I'll stop there. And if you'd like to get in touch, it's always interesting to hear from people. Then I'd be very, very happy to hear from you. So I'm going to stop sharing my screen now, if I can work out how to do that. And I think I'm back.
Thank you. Thank you so much. I knew we were in for a treat. I didn't know quite how much of a treat. And although the internet was a little bit choppy, I think we managed to hear every word. If you have questions for Jonathan, please put them in the Q&A now. We have a few minutes left. Kay
Can I just say that I don't know who you are, Teresa Beddoes, but what a lovely thing to say. She says she's learned more about trees in the last 40 minutes than any other time in my life. I mean, that might say more about the other times in your life than it does about this talk, of course, but it's such a nice thing to have put. Thank you.
Kay Dagan wants to know if trees communicate with each other through their roots.
Yes, so the, I mentioned the those mycorrhizal networks. So the tree roots don't sort of plug directly into another tree's roots. What they have is this sort of go-between, which is a fungus that creates this network of very fine filaments through which both sugars and all those sort of things, the phosphorus and manganese and things that the plant needs are coming one way, and the and sugars going back into the fungus. But also some of these signaling chemicals, they get transferred along these networks as well. Now the thing is, when you say do trees communicate, there is communication, right? So a tree over here that is under attack makes a chemical, the chemical diffuses through those networks and triggers another tree to do something. Now, when you use the word communicate, though, it implies that there's a kind of sentience, it's a sort of a conscious act to communicate. And I think that that's difficult because trees are not animals. But on the other hand, there is a sort of collective intelligence, if you like, in a forest, where we were brought up to think that it's all sort of, trees and plants fighting for light and it's all competition and so on. But actually, there is a bit of cooperation that's going on. And that cooperation is actually sort of better for the forest as a whole, and therefore individual trees as well. So I hope I've kind of answered the question.
I think this is known as the wood wide web in some quarters. One of our viewers, who I'm assuming is a dentist, points out that gutta perca is used for root canal fillings, and they haven't found anything better to use even after 70 years.
Yeah, I was going to say it, and I found myself almost saying dental implants. And then I realized that I'd been corrected about that once. And so I didn't actually say it this time, but thank you for adding that.
Now, Yvonne Cheney, who's one of our regular viewers from Southern California and who tells us she has lots of birds of paradise growing near where she lives, says, is there a reason why when many trees are blown down by high winds in Southern California, she has never seen a palm tree blow down?
Yeah, I mean, palm trees are particularly good at surviving high winds. They've evolved with very sort of flexible stems. They've got this, palms are sort of rather different from most trees in the structure of the sort of woody stuff that, if you cut them through, you don't see tree rings in the same way. And this makes them much, much more flexible. And that's the reason that they don't blow down. And just talking of Strelitzia, the bird of paradise flower, the reason that I forgot to say, the reason those seeds are blue and not sort of like all the other Strelitzias in the world, red or yellow, is because those ruffed lemurs they haven't evolved with the red receptor like we've got, and other primates have. They've only got green and blue. So the plant has kind of accommodated that, and that has blue seeds.
Fascinating. Now, you were talking about climate change towards the end of your talk. Maggie Stratford says, what trees should we be planting bearing climate change in mind? And Chris Pickering says, well, are we actually kidding ourselves that we can overcome climate warming by planting thousands of trees?
Okay, so the first question is, what should we be planting? And in general, planting native trees with a sort of wider genetic provenance as possible is the way to go. And the reason for planting native trees is that they've co-evolved with all those things that sort of spread the seeds and live in and around them. So oaks and birches and ashes and everything else. Now, people who are doing mass planting might also be thinking of taking some trees from maybe a bit further south. Individuals should not be importing trees from abroad. But if you're an organisation that can ensure sanitary, clean trees, and we're not bringing saplings that are infected, then you might be planting chestnuts and oaks from slightly further south in France. Now, the question about, isn't this just tilting at windmills? Planting trees helps, right? But it's certainly not going to avert climate change on its own. However many trees we all plant, and I hope we plant lots, there are lots of benefits to planting trees, not just dragging carbon out of the air, but stabilizing the soil and the climate. Is better for rainfall patterns. It lowers temperature in cities, provides shade, but it also makes people think differently. If they're thinking about trees, they're thinking about the future, and that's a psychological benefit. But you're absolutely right. Not enough on its own. Absolutely, we need to change all sorts of other things. One of the things that we can do is eat less meat, because forests get chopped down to grow crops that we feed to animals, and that's an extraordinarily inefficient thing to do. So just having less meat is a good thing. And the other thing to do, and only governments can do this, is impose carbon taxes. So start small and gradually, and quite rapidly actually, ratchet up carbon taxes, and then the market takes care of So some businesses will go out of business. Some, will probably be taking fewer flights as a result, that kind of thing. But other businesses will flourish, and the market can deal with it. But we really need carbon taxes.
Sophie Rees wants to know, what is your favourite tree, and have you got a good story about it?
It's almost like there's a stooge in the audience. Well, you might remember at the very end of my talk, there was a picture of me sort of leaping in front of a tree, and that's the quiver tree of Namibia. And one of the reasons that I love it is not because it's fantastically resilient and it can live where, thrive where other things just can't grow in the desert. That is amazing. It's a relative of the aloe vera, but a huge thing, 40 feet high. One of the things I love about it is that it's the national tree of Namibia. So when anyone sees this tree, they're smiling. So I like that. And secondly, it's got this kind of slightly powdery surface, actually to reflect ultraviolet light and protect itself, but it makes people want to sort of touch it and stroke it. So the idea of being a tree that is something that people smile at and want to sort of touch in a nice way, I think that's the tree I'd like to be, the quiver tree of Namibia.
Thank you. Now, Linda Rosen says, are tree rings an accurate showing of a tree's age?
Yes, they are. Yeah, they are accurate. So you can count the rings, and the reason that you have tree rings is that trees grow faster in summer than in winter. So you have a sort of the fast bits are a different color from the slow bits. And here's the amazing thing. Here's a bit that I absolutely love about tree rings, is that if you look at the pattern of tree rings over a sort of 10-year period, it goes light, dark, light, dark, light, dark, but the light, dark pattern isn't consistent because some summers will be hotter, some winters will be colder. So you get different sort of lengths, and that provides a signature that you can tell exactly when that tree lived. So if you have a bit of furniture that someone is claiming to be 600 years old, and you look at the tree ring pattern in it, you can say, actually, that's about 40 years old.
Wow.
Clever.
Amazing.
Yeah.
Now, you've written this book, you've written Around the World in 80 Plants. Is anything else in the pipeline?
Yeah, I wish I could say. I'm not sure exactly what's coming next, but there will be something. And I'm sort of busy with that. I'm just typed, someone wanted to know how they can get hold of me. So there's the email address.
There's loads of chat. We don't normally have quite
have you tried an etrog tree? Someone has said the etrog is this fantastic. It's like, for those who don't know, I mean, Jewish people will know what an etrog is because it's associated with one of our festivals. But for others, it's like this. It's the forerunner of the lemon, and it's this kind of thing about that big. I mean, it's a fantastic thing and just amazing scent. And you can make sort of okay marmalade with it, or it's the citron that is used for dipping chocolate in when you get the sort of dipped citron in chocolate, because it's not so sort of bitter and acidic as a lemon would be. And the way that the lemon, or the forerunner of the lemon, more than 1,000 years ago, 1,500 years ago, was taken around the Mediterranean, we think, and by we I mean scientists, not just by me, was encouraged by Jewish people who were moving around the Mediterranean, who were actually bringing this for religious purposes, and that was the thing that spread the forerunner of the lemon around the Mediterranean, which I sort of rather like, really.
And they're slightly more expensive than lemons. In fact, considerably more expensive than lemons. Now, if you want to buy a copy of Around the World in 80 Trees, there will be a link in the follow-up email that you'll get tomorrow. Or if you're at any other Leeds LitFest events at the Leeds Library, you'll be able to buy a copy there.
Now, you might see this one somewhere as well. There's a paperback version, and so the two different covers, same inside.
Thanks for sharing that. We didn't know, so now we do. Now, you have already got my book about the Israeli ambulance service, so I'm going to send you something very special. This is some of my photographs of vegans in Iceland.
Wow.
Hope you'll enjoy that. It's probably the most obscure book title in history. Now, a few words about our future programme before we go. This Wednesday, we have another Leeds Litfest event. I'll be chatting to Barrington Black about his latest book, The Jewish Contribution to British Law. You can come and hear this in person at the Leeds Library, or you can watch the live stream online. Future Milim events continue on Monday, the 7th of March, with another hybrid event. Writer Menachem Kaiser joins us in person, visiting from his home in Brooklyn and fresh from Jewish Book Week. Menachem will be in conversation with me about his recent book, Plunder, a compelling memoir of family property and Nazi treasure. He will be at the UHC Leeds, or you can watch the event streamed online if you prefer. On Monday, the 14th of March, our very own Ian Vellins returns to Milim to tell us about Tom Stoppard with a presentation called Becoming Jewish Again. And then the following week, on the 21st of March, we have a real treat for you. Milim is delighted to present Howard Jacobson. He and I will be discussing his latest book, a memoir, Mother's Boy, which will be published later this week. And finally, for now, on the 28th of March, we partner with the Jewish Historical Society of England Leeds branch to welcome Dr. Chelsea Sambells from the University of Huddersfield and the Holocaust Centre North. Chelsea is speaking about the lesser-known legacies of the Nuremberg trials. Please do visit our website at milim.org.uk to book your tickets and make sure you don't miss out on anything. All of our events are free. But you can help us with a small donation as ever. It remains for me to thank our guest, John Drury, once again. Thank you so much for being with us, John.
Thank you. And to Joy, who's just pointed out that I said Ponte Vecchio rather than Rialto. You're right. I just, when you're speaking, you sometimes just say the wrong thing.
Well spotted, Joy. And looking forward to seeing you all at a future event. Until then.